Welcome back to The Explainer. I am absolutely thrilled to have you here today because we are looking at something totally fascinating. We're exploring the hidden, highly skilled craft that literally holds our modern world together. I mean, think about this for a second. We're talking about harnessing temperatures hotter than the surface of the sun just to bind pieces of metal together so perfectly that they become a single unbreakable structure. We pass by the results of this extreme science every single day. We trust our very lives to it, and yet most of us never give it a second thought. Today, we are talking about the incredible world of global welding innovation and the absolute titans who built it from the ground up. Okay, let's dive into this. What really holds our world together? When you look up at a towering 60-story skyscraper, or when you're driving across one of those massive steel suspension bridges over a churning river, consider what those structures are actually enduring. They are constantly battling thousands of tons of dynamic pressure, crazy extreme temperature fluctuations, violent wind shear. The forces actively trying to rip them apart are immense. So, what are the vital, unseen seams keeping all of that intact against such overwhelming odds? Well, it's not magic. It's the result of one of the oldest, most critical metalworking skills in human history. All right, moving to section 1, the invisible global glue. Let's establish the massive scale and the stakes of this craft. And this brilliantly illustrates what we're talking about here. This isn't just about joining two pieces of metal in a garage on a Sunday afternoon. This is the foundational engineering that underpins our entire global infrastructure. Every major multi-billion-dollar sector you can think of completely depends on this elite craftsmanship. Take shipbuilding. A modern cruise ship contains literally thousands of miles of structural welds holding back millions of gallons of ocean water. Or aerospace engineering. When you're welding components for a spacecraft, there is absolute zero tolerance for error because, well, the freezing vacuum of space is right on the other side of that seam. Whether it's the towering cranes in construction, the high-pressure pipelines in oil and gas, or the intricate robotic assemblies building our cars, none of it functions without highly skilled fabricators. It's the invisible glue of the entire global economy. That brings us to section 2, igniting the modern arc. And the origins of this craft actually stretch way further back than the industrial age. So get this. Thousands of years ago, the ancient Egyptians were actually utilizing early forms of forge welding. To understand forge welding, imagine heating pieces of metal in a roaring fire until they are glowing red hot and soft, and then literally smashing those pieces together with a heavy hammer until they fuse into one. It was raw, it was exhausting, and for its time, it was revolutionary. But the giant leap forward, the transition to the modern world we'd recognize today, required a totally different energy source. Fast forward to 1882. An inventor in Russia named Nikolay Benardos introduces carbon arc welding. Instead of just heating metal in a fire, Benardos harnessed electricity. Carbon arc welding uses a continuous electrical spark, an arc, leaping between a carbon electrode and the metal itself. This continuous spark generates such immense, localized heat that it instantly melts the metal into a liquid pool. This single invention was a total game changer. I mean, it laid the absolute foundation for modern structural integrity. Let's move to the timeline and see how this builds, because it's a stunning evolution. We start thousands of years ago with the ancient fires of Egyptian forge welding. Then, boom, we hit 1882 with that Russian invention of carbon arc welding by Benardos, unleashing the raw power of electricity. But as we move into the 20th century, engineers hit a massive roadblock. It turns out molten metal reacts very poorly to the oxygen in the air. If oxygen gets into that liquid weld pool, the joint gets brittle and full of microscopic bubbles. Not good. The brilliant solution? The introduction of coated electrodes. The chemical coating on the welding rod is designed to literally burn away as you weld, which creates this protective cloud of shielding gas. This invisible gas shield actively pushes the oxygen away, keeping the weld pure and incredibly strong from the inside out. That single innovation dramatically improved safety and quality, paving the way for today's landscape, where we've got incredible robotic automation working right alongside elite human precision. Section 3, Titans of the Trade. So the crucial point is that these historical innovations were driven by brilliant minds solving massive industrial problems. Now, what's really interesting about this slide is the sheer global scale of these titans. These weren't just guys tinkering in sheds, they were pioneers tackling the exact same massive challenges from completely different corners of the globe. We already mentioned Nikolay Benardos in Russia pioneering the carbon arc, but look at the parallel breakthroughs with those coated electrodes we just talked about. Over in the US, an engineer named C.J. Holzlag was developing coated electrodes to stabilize the arc. At almost the exact same time in Sweden, Oskar Kjellberg founded ESAB and independently invented a heavily coated electrode that totally revolutionized the strength of arc welding globally. Meanwhile, back in the US, James F. Lincoln had a realization. He knew the best tech in the world is completely useless without skilled operators. So through the Lincoln Electric Company, he heavily prioritized the human element: education, research, teaching generations how to safely master this dangerous power. You also have Howard B. Carey writing the definitive textbooks that shaped modern curriculums. Up in Canada, Terry Osgood became this renowned inspector fiercely protecting high industry standards. In Japan, Masami Uchida made massive contributions to the automated robotic welding that safely builds our cars today. And all the way down in Australia, Professor John Norrish pushed the very boundaries of welding metallurgy. By focusing on everything from the chemistry of the spark to the education of the operator, these global pioneers created the modern safety standards that keep us all secure today. It's a massive worldwide effort. Moving to Section 4, the global welding stage. Today, this isn't just manual labor, it is an elite precision craft on a global stage. You know, a fascinating reality of this profession is that, unlike traditional sports, there's no official, unified ranking of the world's best welders. There's no FIFA World Ranking or Olympic gold medal leaderboard ranking every fabricator on Earth. But, make no mistake, that doesn't mean excellence goes unnoticed. Actually, scratch that. It is measured with terrifying precision. Professionals in this field earn immense international recognition through non-destructive testing. A master welder's work isn't just eyeballed, it is subjected to industrial X-rays and ultrasonic testing. Their welds are scrutinized at a microscopic level, searching for tiny hairline fractures or internal bubbles that could compromise a high-pressure pipeline or an aircraft fuselage. Their entire reputation is built on life-saving precision and an unwavering commitment to flawless quality. And while there isn't a single global leaderboard for every individual, there is an incredibly intense arena where the best of the best actually go head-to-head. Professional welders compete in international skills competitions like World Skills. And guys, this isn't just a basic metalworking test. Competitors are handed incredibly complex engineering blueprints and are asked to join exotic, difficult metals under immense time pressure, with zero room for error. Nations like China, South Korea, Germany, Japan, Brazil, and Switzerland consistently dominate this modern arena. They pour immense resources into training, producing world-class engineers and fabricators who treat the welding arc like a surgical tool. They're constantly proving that mastery of this craft is a relentless global pursuit of absolute excellence. Which brings us to our final thought for today's explainer. Next time you cross a steel suspension bridge, board a commercial airliner, or stand near the top of a towering skyscraper, who are you going to think? From the extreme, sweaty heat of the ancient forge to the brilliant global titans who tamed the electric arc, right down to the microscopic, X-rayed perfection demanded of modern fabricators, I really hope this explainer has given you a profound appreciation for the invisible craftsmanship that literally surrounds you. It is the masters of the arc who keep our modern world safely held together. Keep looking for those incredible hidden structures in your everyday life, and keep questioning how the world around you is truly built. Thanks for joining me, and I'll see you in the next one.